Right at this exact second, there are millions of tons of raw biological material just hurtling across
Oh,
oceans.
yeah. In steel containers, baking in trucks on highways.
Exactly. I mean, just passing through thousands of human hands, we pull living matter from the dirt, from the deep ocean, from massive agricultural grids, and we ship it across multiple time zones before it eventually lands right on your plate.
And honestly, by all the laws of biology and entropy, this global food web should just be a nonstop engine for disease.
Right. We should be constantly violently ill.
We really should.
But we aren't. We just kind of, trust the system. So today we're looking at the invisible geopolitical source code that prevents total biological chaos and just keeps the global food supply chain functioning.
Because when you look at the sheer velocity of modern trade, the fact that we don't live in a state of continuous gastrointestinal terror comes down to an incredibly rigid, universally applied structural framework.
Yeah.
It's an engineering marvel, the one made of rules rather than concrete.
Welcome to the deep dive. We are not tackling a flashy historical narrative or a true crime thriller today. We are looking at a foundational blueprint of human civilization. We are unpacking a table of contents that quietly keeps the world alive.
That's a great way to put it.
Our source material today is the Codex Alimentarius Food Hygiene Basic Texts, 2nd edition. And this was issued by the joint FAO-WHO Food Standards Program published in Rome back in 2001.
Right, and the title itself, Codex Alimentarius, that translates directly from Latin as food code.
Food code, okay.
Yeah. And these specific basic texts on food hygiene, they represent the absolute bedrock principles. Principles intended to ensure that a piece of food is safe to consume, regardless of where on the planet it was grown, harvested, or processed.
Which is wild.
Yeah.
So our mission for this deep dive is to essentially reconstruct the entire life cycle of safe food, from the soil to your stomach, strictly by analyzing the architecture of this international rulebook.
It's quite a journey.
It is. Okay, let's unpack this. Think of the Codex as the invisible operating system running the global food network.
I like that analogy.
Right, because when you boot up your computer, you don't look at the millions of lines of machine code routing power to your graphics card. You just see your desktop.
Exactly.
When you walk into a grocery store, you don't see the Codex. You just see a perfectly uniform row of shiny apples.
And if we run with that operating system analogy, the table of contents serves as the root directory of the source code. But to understand the physical reality of the food supply, I actually prefer to view this table of contents as the architectural blueprints of a massive, heavily fortified compound.
Oh, fortified compound. Okay, I can see that.
Right, because when you examine a blueprint and you see where the architect placed, the thickest walls, the deepest moat, the heaviest blast doors.
You know where they think the attack is coming from.
Exactly. You immediately understand where the compound is most vulnerable. By showing us exactly where the operational defenses are built into this document, the authors are showing us precisely where our food is most at risk of being compromised by microscopic invaders.
Wow. Okay, so let's establish who these architects actually are and the geopolitical reality they were operating in back when this was drafted.
It's a huge collaboration.
Yeah, we're looking at the publishing notes right at the beginning of the text, before we even hit the Roman numerals of Section 1. This document is a collaboration between two massive global entities. You've got the Food and Agriculture Organization of the United Nations, the FAO, and the World Health Organization, the WHO.
Two absolute heavyweights.
Totally.
You have the FAO, which is an agency whose primary mandate is defeating hunger, improving agricultural efficiency, ensuring global food security. And then you have the WHO, which directs and coordinates international health and epidemiological responses.
From the disease side of things.
Exactly. So the Joint Food Standards Program forces this marriage between the gritty, boots-on-the-ground reality of agricultural production and the clinical, microscopic reality of disease prevention.
And what stands out in these opening pages isn't just the pedigree of those organizations, but there's a very specific legal disclaimer sitting quietly on the copyright page.
Oh, the boundary disclaimer, yes.
Yeah. It states that the designations employed in this publication do not imply the expression of any opinion whatsoever on the part of the FAO or WHO concerning the legal status of any country, territory, city, or area, or of its authorities, or concerning the delimitation of its frontiers or boundaries.
It's quite a mouthful.
It is. But you read a disclaimer about the delimitation of frontiers, and you immediately realize you aren't just reading a kitchen hygiene manual, you are reading a geopolitical treaty.
You really are. And the explicit removal of politics from the text, Well, it's a functional necessity
How so?
because food safety fundamentally has to transcend political conflicts and border disputes. The threats to food safety pathogens like Salmonella, Listeria, E. coli, they do not carry passports.
Right. They don't care about borders.
Exactly. A microbe does not recognize a demilitarized zone.
Right.
It doesn't care about a disputed borderline drawn on a map. If water flows from a contested territory into a neighboring region, and that water is utilized to irrigate a field of lettuce,
The pathogen just travels with the water.
completely indifferent to human geopolitical squabbles. Therefore, the Codex must be universally applicable. It has to be a framework that two nations who might currently be engaged in a hot war can both implement.
That's a crazy thought. Two nations at war agreeing on how to wash a tomato.
It is. The FAO and WHO are essentially establishing that while they hold no jurisdiction over who claims a piece of land, they absolutely dictate the biological reality of how a tomato grown on that land must be handled.
I have to challenge the practicality of that neutral ground concept, though.
Fair enough.
You say this creates a neutral framework devoid of politics. But in reality, if two countries are locked in a bitter trade war, couldn't country A just weaponize these safety metrics?
That happens all the time.
Right. Couldn't they arbitrarily claim that country B's grain shipments are, too risky or fail to meet the Codex standards just to block their exports and protect their own domestic farmers? How does a book of hygiene rules actually prevent regulatory protectionism?
That is the exact vulnerability the World Trade Organization deals with constantly. Countries using what they call phytosanitary measures as a disguise for illegal trade barriers. But the Codex prevents arbitrariness by forcing the language of dispute into the realm of hard science.
Okay, so it removes the vague language.
Right. If country A wants to block country B's grain, they cannot just vaguely claim it's unsafe. Under the framework supported by the Codex, country A has to provide the mathematical risk assessment proving the presence of a specific hazard at a specific threshold that violates a scientifically established limit.
Wow, okay, so it's about data.
Exactly. A bacterial growth curve operates identically in a capitalist democracy and an authoritarian regime. The Codex strips away the ideological rhetoric and forces both sides to argue over laboratory assays and parts per million.
That explains why Section 2 of the document is entirely dedicated to scope, use, and definitions.
Setting the terms.
Right. Before they instruct anyone on how to build a facility or clean a surface, they mandate a universal vocabulary. I mean, you can't adjudicate a trade dispute over a contaminated shipment if one country's definition of clean means visually free of dirt, and the other's definition means microbiologically sanitize to a logarithmic reduction.
Defining the terminology is the prerequisite to enforcing the law. Once the parameters of the language are locked in, the Codex can actually begin to track the physical journey of the food.
And that journey starts before the food is even a product. It starts in the dirt, the water, and the natural environment. So let's dig into Section 3 of the Table of Contents. Primary reduction.
This is the absolute starting line. The farm, the orchard, the open ocean. It is the human interaction with the untamed natural world.
The subcomponents here paint a very specific picture of how a safety regulator views nature. We have environmental hygiene, hygienic production of food sources, handling, storage, and transport, and finally, cleaning, maintenance, and personnel hygiene at primary production.
A lot of different layers there.
There are. Let's focus on that first distinction. They separate environmental hygiene from hygienic production. It feels akin to preparing a nursery before a baby arrives.
Oh, I like that.
Right. You don't bring a newborn into a room and then start testing for lead paint or checking if the window lets in freezing drafts. You evaluate and sanitize the environment long before the vulnerable occupant arrives.
The distinction between the environment and the production process reveals the underlying philosophy of the Codex at this stage. Environmental hygiene is the assessment of baseline, uncontrollable risks in the natural world.
Uncontrollable risks? Like what?
Well, it requires a producer to ask things like, is this soil heavily contaminated with heavy metals from a historical industrial site? Is the local aquifer pulling in agricultural runoff rich in fecal coliforms? You are evaluating the natural canvas before you paint on it.
Because if you plant a crop in toxic soil, it literally does not matter if your harvesting tractors are perfectly sterilized.
No, it doesn't.
The food is fundamentally compromised from the root up. You cannot outmanage a poisoned well.
Exactly. Only after the baseline environmental risk is deemed acceptable, or at least quantifiable, does the Codex move to hygienic production.
Okay, so moving from the canvas to the painting itself.
Right. This shifts the focus from evaluating nature to managing human intervention. This covers the actual mechanisms of farming. How exactly is the fertilizer being applied to ensure it doesn't splash onto the edible portion of the plant?
Ah, okay.
What are the protocols for pulling a fishing net out of the water to prevent cross-contamination from the vessel's deck? It's about the physical actions.
But then, still under this primary production umbrella, we hit handling, storage, and transport, as well as cleaning and personnel hygiene. To a layman, a farm is just a place where things grow. But the Codex treats the farm as the very first industrial storage facility.
It absolutely is.
Right, the harvested wheat sits in a massive silo, the raw milk sits in a chilling tank in the barn.
Because the biological reality of a harvested crop is that it begins decaying the second it is severed from the earth or the
The
animal.
clock starts ticking immediately.
It really does. When you harvest a head of lettuce, it's still respiring. It is taking in oxygen and generating heat. If you pack 1,000 heads of lettuce into a bin in the middle of a hot field, that biological heat accelerates microbial proliferation exponentially.
Just baking in its own heat?
Yeah. So handling and storage at the primary level are about immediately halting that biological clock, usually through rapid field chilling or desiccation.
Now, why do they place a specific section for personnel hygiene and cleaning here in Section 3 when we know there are massive, incredibly detailed chapters dedicated to those exact topics later in the document?
So it seems redundant, right?
It does. Why not just write one master chapter on how to wash hands for the entire supply chain?
Because context dictates the protocol.
Okay.
The logistical reality of enforcing personnel hygiene in the middle of a muddy 500-acre agricultural field during a rapid harvest is entirely different from enforcing hygiene inside a climate-controlled, sterile processing plant.
That makes a lot of sense.
The Codex acknowledges that a field worker doesn't have access to a sensor-activated sink and an airlock. Establishing a defense perimeter in the dirt requires pragmatic, environment-specific solutions, like mobile sanitation stations and specific protocols for dealing with wildlife intrusion in the fields. You have to secure the perimeter at the source before the raw material ever reaches the back of a truck.
Wow. Okay, so once that raw material is secured, it has to be brought inside for processing, packaging, or cooking. We are leaving the chaotic, open-air environment of the farm and entering the highly controlled structural requirements of Section 4, which is titled Establishment, Design, and Facilities.
This is where that architectural blueprint analogy really takes shape.
Section 4 represents the static architecture of food safety. It is the unmoving physical barrier between the food and the outside world. And the table of contents lays out a highly logical, telescoping progression here. It starts wide with location, then zooms into premises and rooms, zooms in further to equipment, and finally to facilities, which covers utilities like water and air.
Let's follow that zoom. Starting from a satellite view with location. We aren't just talking about an address.
Right.
We are talking about geographical vulnerabilities. Is this processing plant zoned next to a waste treatment facility? Is it located in a valley where prevailing winds will carry chemical dust from a neighboring manufacturing plant straight into its ventilation intakes?
So you have to engineer the location before you pour the foundation.
Absolutely. And from the location, you move inside to the premises and rooms. This is where material science and engineering physics become food safety tools.
Oh, the building materials themselves?
Yes. The Codex dictates that floors cannot simply be flat. They must be sloped at precise angles so that water, blood, or chemical runoff continuously flows toward drains, preventing stagnant pools where biofilms can form.
Wow, even the floor angle.
Even the floor angle. And walls cannot have sharp 90-degree angles where they meet the floor. They must be curved, so that mechanical scrubbers can reach every millimeter of the surface without leaving a harbor for bacteria.
Because a right angle is basically a safe haven for microbes.
Exactly. Then we zoom into the equipment, you look at a food processing line, and everything is gleaming stainless steel.
Right.
That isn't for aesthetics. The Codex fundamentally outlaws porous materials like wood in high-moisture processing areas, because a microscopic groove in a wooden cutting board is a canyon where thousands of bacterial cells can hide from chemical sanitizers.
A canyon. That's a terrifying visual.
That's accurate. And finally, the facilities section covers the invisible architecture, the utilities. Ventilation systems have to maintain positive air pressure in high care zones, meaning when a door opens, the clean air rushes out, preventing the contaminated air from rushing in.
But the critical thing to grasp about Section 4 is its passivity, right?
Yes.
A beautifully engineered facility with perfectly sloped floors, coved walls, and positive air pressure does absolutely nothing on its own. It is an empty, sterile shell.
A fortress with no soldiers.
Exactly. The true test of the fortress only begins the moment you turn on the conveyor belts, bring in 100 hired workers, and start pumping thousands of pounds of raw, biologically active material through the doors.
Which brings us to the collision of the static building and dynamic reality. Section V, control of operation.
Right. Let's look at the mechanisms they deploy to manage this invasion of raw material. We have control of food hazards, key aspects of hygiene control systems, incoming material requirements, packaging, water, management and supervision, documentation and records, and recall procedures.
Managing an operation is essentially managing a symphony of interlocking variables. You must monitor the incoming material requirements at the loading dock, ensuring the temperature of the arriving trucks hasn't spiked during transit.
Because if it did, the whole batch is already ruined.
Exactly. You must evaluate the packaging, because if a roll of plastic film was stored in a dusty warehouse, wrapping clean food in that film immediately compromises the product. You must constantly test the water, which is the lifeblood of the facility, used as an ingredient, a transport medium, and a sanitizing agent.
Here's where it gets really interesting to me. I'm looking at the placement of recall procedures here. It's nested directly under control of operation, right alongside daily tasks like monitoring water and keeping records. Intuitively, I would expect recalls to be placed at the very back of the book in a panicked appendix labeled "in case of catastrophic failure."
Most people would.
But here it is, treated as a mundane operational step.
Placing recall procedures inside standard operations is a profound statement on statistical realism. When you are processing millions of units of food, failure is not a hypothetical anomaly. It is an eventual mathematical certainty.
Something will go wrong.
A mechanical blade will eventually snap and leave a metal shard in a batch of dough. A raw ingredient will eventually slip past the screening with a high microbial load.
So it's not the arrow accidentally fired into the village. It's more like a software patch. You realize a specific line of code is causing a system error, and you push an update to isolate and quarantine that bug before the entire network crashes. The supply chain is just the hardware running that software, and the recall is the patch.
That is a much more accurate framework. A recall does not indicate that a company lacks a safety system. A rapid surgical recall that pulls a specific batch of product off shelves before anyone falls ill is the ultimate proof that the safety system is functioning exactly as designed.
That's completely counterintuitive, but it makes total sense.
Right. The facility possesses the telemetry to identify the failure and the operational mechanisms to retrieve the compromised units. Denying that failure will happen is how you end up with a crisis. Planning for the retrieval is how you maintain control.
So we have the passive architecture of the building and the dynamic chaos of the processing operations. But the moment those two interact, the building begins to degrade. The floors get covered in organic matter, the equipment vibrates and loosens, the drains fill up. How does a global system fight the physics of decay?
Enter Section 6.
Section 6, establishment, maintenance and sanitation.
If Section V is the battle raging inside the fortress, Section 6 is the crew tirelessly repairing the walls and clearing the debris while the battle is happening. Entropy is the constant enemy of food safety.
The attack vectors in this section are divided into maintenance and cleaning programs, pest control systems, waste management, and monitoring effectiveness. It's a continuous multi-front war.
It really is.
You have to physically remove the organic grime through cleaning. You have to keep the rodents and insects out through pest control, and you must constantly extract the garbage through waste management. These systems are entirely interdependent, aren't they?
Oh, totally. If your waste management protocol fails and dumpsters overflow near the loading dock, you immediately attract pests,
Right.
which then breach the facility and compromise your cleaning programs. It's a domino effect. But the most dangerous threat in a facility isn't the dirt you can see, it's the biology you can't.
Okay, tell me more about that.
When organic matter mixes with water on a surface and isn't completely eradicated, bacteria secrete a sticky matrix called a biofilm.
A biofilm, like slime?
Yeah, essentially. This biofilm acts like a microscopic bunker, protecting the bacteria underneath from standard chemical sanitizers. Overcoming biofilms requires mechanical scrubbing and aggressive chemical rotation, which is why the Codex mandates formal, documented cleaning programs, not just ad hoc wiping down of tables.
But how do you prove the invisible bunker is gone? I mean, you can have a 3-inch thick binder documenting your cleaning schedule. You can have the best pest control traps on the market. But if you can't see the bacteria, how do you know the protocol actually worked?
That is the function of the final subcomponent in this section, monitoring effectiveness.
The feedback loop.
Exactly. This is the critical feedback loop. A documented cleaning program is merely a hypothesis that a surface is clean. Monitoring effectiveness tests that hypothesis through empirical data.
Oh, wow. So they're actually testing it.
Yes, it requires a quality assurance technician to walk onto the production floor, take a swab of that coved stainless steel corner after it has been chemically sanitized, and incubate that swab in a laboratory to see if bacterial colonies form.
So there's nowhere for the bacteria to hide.
Exactly. It also requires auditing the pest control logs to track seasonal infestation trends.
Yeah.
Without the empirical feedback loop of monitoring, the rest of the sanitation section is dangerously reliant on blind faith.
Okay, we have engineered a pristine location. We have constructed an impervious facility. We have implemented a rigorous operational flow, and we are aggressively fighting entropy through scientifically monitored sanitation. By all physical measures, this system is airtight.
It looks perfect on paper.
But a perfectly engineered system is entirely reliant on the entities operating it.
Which brings us to the most unpredictable, chaotic, and dangerous variable in any safety matrix: the human being.
Let's dive into step 3 of our journey, the human element. The Codex addresses the human variable in 2 distinct sections. First, we have Section 7, Establishment, Personal Hygiene, and then later, almost as a capstone to the main text, we have Section X, Training. Let's start by deconstructing personal hygiene. The subcategories are health status, illness and injuries, personal cleanliness, personal behavior, and visitors.
It is genuinely fascinating to read a geopolitical text that is forced to dictate the intimate personal habits and bodily functions of millions of individuals across thousands of distinct cultures.
It really is. The first 2 categories, health status and illness and injuries, are straightforward biological exclusions. If an employee is shedding a communicable virus like norovirus, or if they have an open infected laceration on their hand, they are a direct biological hazard. You protect the food by physically removing the human from the processing environment.
Yes, that is the most basic level of quarantine. But the Codex quickly moves into the much more difficult territory of managing healthy humans.
And this is where I find a crucial distinction in the text. Why does the Codex separate personal cleanliness from personal behavior? If an employee is clean, aren't they safe? What does behavior encompass that cleanliness misses?
It is the difference between a static state and a continuous action. Cleanliness is a temporary physical state.
A temporary state.
Right. An employee can arrive at a facility, pass a health check, aggressively scrub their hands at an automated wash station for the required time, don a pristine smock, a hairnet, and sanitized gloves. At that specific moment, they satisfy the requirements of personal cleanliness. They are essentially a sterilized tool.
But they're still a human being.
Exactly. And human beings are governed by deeply ingrained unconscious reflexes. An hour into a shift on a fast-moving assembly line, that perfectly clean worker might reach up and absentmindedly scratch their nose. They might adjust their safety glasses, wiping sweat from their eyebrow. They might sneeze into their shoulder or chew on a pen while checking a clipboard. Those actions instantly shatter the state of cleanliness.
Wow.
That is personal behavior. You can mandate cleanliness with a sink and a bottle of soap. Modifying behavior requires continuous psychological vigilance to suppress natural human reflexes for 8 hours a day.
That seems like an impossibly tall order. You are asking a workforce, often performing highly repetitive, physically exhausting labor, to maintain a state of hyper-awareness regarding every microscopic movement their body makes. I mean, facility design can force some of this, like boot scrubbers you have to physically walk through to unlock a door, but you can't engineer out a sneeze.
Which is precisely why the Codex cannot rely on rules alone. It requires cognitive modification. This is why Section X, Training, is its own dedicated pillar. The Codex recognizes that you cannot simply command humans to override their nature without providing continuous education on the consequences.
Looking at Section X, the progression of the training is very deliberate. It moves from awareness and responsibilities to formal training programs, to instruction and supervision, and finally, refresher training.
The starting point, awareness, is vital. An employee cannot simply be given a list of rules. They must be taught the why behind the rule.
Give them the reason.
Exactly. If a manager simply yells, "Keep your gloves on," a tired employee will eventually take them off when no one is looking because gloves are uncomfortable. But if you instill awareness, if you explain the microbiological reality that Staphylococcus aureus lives naturally on human skin, and that transferring it to a batch of infant formula could cause a lethal outbreak, you shift the motivation from mere compliance to moral responsibility.
That is powerful. You train them, you supervise them, but the inclusion of refresher training as a mandated subcategory is what really grounds this in reality to me. It is a formal admission of human frailty. Knowledge decays, urgency
It
fades.
really does.
A worker might be terrified of cross-contamination during their first week on the job, but by day 300, the machinery is loud, the line is moving fast, they're thinking about their mortgage, and complacency sets in. Refresher training acknowledges that the human attention span has a half-life, and you have to constantly inject new awareness into the system to prevent the safety culture from degrading.
Well said. The stainless steel tables in Section 4 do not get bored. The air pressure systems do not get complacent. Only the human variable requires a psychological maintenance schedule.
So let's track the physical location of our hypothetical food product. It was harvested from an assessed environment. It was processed inside an impenetrable, relentlessly sanitized fortress. It was handled by healthy workers who suppressed their natural behaviors through rigorous training. It is now sealed in its packaging. The fortress has done its job. But now, the food has to leave the compound. It has to go out into the uncontrolled world.
We are entering Step 4, the vulnerable middle and the ultimate transfer of liability.
Section 8 is dedicated entirely to transportation. The Codex dictates general requirements, use, and maintenance of transport vehicles. It's brief, but the implications are massive.
Transportation is a high-wire act. You take a perfectly stabilized product, seal it inside a metal box on wheels, and hurl it down an interstate highway system through a desert.
It's terrifying when you phrase it like that.
But that's what it is. The truck is essentially a mobile, high-risk extension of the facility. If the refrigeration telemetry on that trailer fails during a heat wave and the internal temperature spikes for 4 hours, every single safeguard engineered in Section 4 and every hour of training in Section X is rendered completely meaningless.
The biological clock starts ticking again.
Exactly, and pathogens multiply exponentially.
Assuming the cold chain holds and the truck survives the journey, the food arrives at a distribution center and eventually the retail grocery store. It sits on a shelf. And then a consumer walks down the aisle and places it into their cart. This initiates Section 9X, product information and consumer awareness. This is the baton pass from the global supply chain to the individual.
And the Codex handles this transfer through rigorous documentation. Look at the structure: lot identification, product information, labeling, and consumer education.
Let's break down lot identification. Earlier, we talked about recalls acting as a software patch. The lot ID is the IP address that allows you to target that patch.
Precisely. A lot ID is a unique alphanumeric code printed on the packaging that links that specific physical item to a massive web of data. It tells the manufacturer exactly which field the primary ingredient came from, which specific processing line handled it, the exact time it was packaged, and which truck delivered it.
It's a complete biography of the food.
Yes. If a cluster of illness is traced back to a specific brand of peanut butter, the lot ID allows regulators to surgically excise the contaminated batches from the market without having to destroy the entire national supply of peanut butter. It contains the economic fallout while neutralizing the biological threat.
Alongside the lot ID is the labeling. The Codex views the label not as real estate for marketing, but as a critical safety document communicating directly with the outside world. It dictates allergens, expiration dates, and critical instructions like keep refrigerated or cook to an internal temperature of 165 degrees Fahrenheit.
Which brings us to the final and arguably most precarious step in the physical food chain: consumer education.
The text pleads for consumer education, and it's not just a courtesy, it's an admission of liability transfer. The FAO and WHO, these massive international bodies, are acknowledging a terrifying reality. All the geopolitical neutrality, all the stainless steel engineering, all the cold chain telemetry, and all the microbiological math cannot save a consumer who takes the product home and mishandles it.
The consumer is the final, entirely unregulated food handler. Think about the average home kitchen. It does not comply with the design and facility requirements of Section 4.
Definitely not.
The consumer does not utilize a coved stainless steel prep table. They use a porous wooden cutting board. They do not have a swab-verified cleaning program. They have not undergone refresher training on cross-contamination.
Right.
A consumer might unpack raw chicken, wash it in the sink, which only aerosolizes the bacteria around the kitchen, wipe their hands on a shared towel, and then use the same knife to chop vegetables for a raw salad.
The global fortress escorts the food safely for thousands of miles, right up to your front door. But the moment it crosses the threshold of your kitchen, the Codex has zero jurisdiction. You are entirely on your own, armed with nothing but the instructions printed on the label.
Which is why the Codex urges governments to invest in broad consumer education. Because the system's ultimate success or failure is determined by a tired parent rushing to make dinner on a Tuesday night.
We have mapped the physical and operational journey of the food. But throughout this entire deep dive, we've talked about these invisible threats: salmonella, listeria, biofilms, temperature spikes. How do the architects of the Codex actually measure these ghosts? How do you calculate the invisible variables across millions of miles of supply chain? To understand that, we have to move out of the basic texts and into the heavy scientific engines that power the entire global framework.
We are moving into the appendices and guidelines attached to the Codex. This is where the theoretical rules are translated into hardcore, applied mathematics.
The most famous engine in this annex is the Hazard Analysis and Critical Control Point System and guidelines for its application. In the industry, this is universally known as HACCP.
HACCP is the central nervous system of modern food safety engineering. And its origins are actually fascinating. It wasn't developed by agricultural regulators at all.
Really? Who developed it?
It was developed in the 1960s through a collaboration involving NASA. Yes, NASA. They needed to ensure that the food going into space with the Apollo astronauts was absolutely 100% free of pathogens. A standard foodborne illness like a norovirus outbreak is unpleasant on Earth. In a zero-gravity space capsule, it would be a catastrophic mission failure.
I can't even imagine. But you can't just cross your fingers and hope the space food is safe. But you also can't test every single ounce of food, because to test food for bacteria, you usually have to destroy it in a lab. If you test everything, you have nothing left to eat. So how does HACCP solve that paradox? What exactly is a critical control point?
Well, since you cannot scientifically measure every molecule of food at every second of its journey, HACCP requires a facility to map out its entire operational flowchart, every single step from receiving to shipping, and identify the critical control points, or CCPs. A CCP is a specific, measurable step in the process where a control can be applied that is absolutely essential to prevent, eliminate, or reduce a food safety hazard to an acceptable level.
Let me try to visualize this. Imagine a massive river that periodically floods and destroys a town downstream. You cannot afford to build a 100-mile-long concrete wall along the entire bank of the river. It's economically and logistically impossible. However, if you survey the geography, you might find a narrow gorge upstream. That gorge is a critical control point. If you focus all your engineering resources on building a single, highly monitored dam right at that gorge, you can control the flow of the entire river and save the town.
That is an excellent visualization. In the context of a dairy processing plant, the pasteurization machine is the dam in the gorge. Raw milk contains inherent biological hazards. The CCP is the application of an exact temperature, say 161 degrees Fahrenheit, for an exact duration of 15 seconds.
Because that's the lethal threshold.
Right. This thermal death time is mathematically proven to eliminate target pathogens. If a sensor detects that the temperature dropped to 159 degrees for even 1 second, the CCP has failed, the dam has broken, and the system automatically diverts that milk back through the loop. HACCP is the process of finding those gorges in the production line and guarding them relentlessly.
But how do the engineers know how high to build the dam? How do regulators know that 161 degrees is the magic number, or which specific bacteria they're even trying to kill? That brings us to the final and most intellectually dense section of the table of contents: the principles and guidelines for the conduct of microbiological risk assessment.
This is the raw microbiological math. This is the scientific methodology that informs every rule, every CCP, and every geopolitical trade dispute we discussed earlier.
The text lays this out as a strict 4-step scientific model. Let's walk through it by applying it to a real-world scenario. Let's say we are evaluating the risk of Listeria monocytogenes in a facility producing soft, unpasteurized cheese. Step 1 is 4.3, hazard identification.
Hazard identification is the qualitative starting point. It requires regulators to review epidemiological data and name the specific threat. In this case, the hazard is Listeria. We know it is prevalent in dairy environments, and we know it has the dangerous, unique ability to continue multiplying even at cold refrigeration temperatures. You have isolated the enemy.
Got it. Step 2 is 4.4, exposure assessment. We know the enemy is Listeria, but exposure assessment asks, how much of this enemy is the consumer actually going to encounter?
This is where the supply chain telemetry becomes vital. The risk assessors have to calculate the likely dose. If a few cells of Listeria contaminate the cheese at the plant, how much will that bacteria multiply during the 3 days it spends on a refrigerated truck and the 5 days it sits in a grocery store display case?
Oh, because it grows in the cold.
Exactly. Exposure assessment models the growth curve based on time and temperature abuse to estimate the exact number of bacterial cells that will be present on the cheese at the exact moment the consumer puts it in their mouth.
Step 3 is 4.5, hazard characterization. Now, I need some clarity here. How is hazard characterization different from step 1, hazard identification? We already know the threat is Listeria. What more are we characterizing?
Hazard identification simply names the weapon. Hazard characterization quantifies the damage the weapon inflicts on the human body.
Ah,
It requires establishing a dose-response curve. If a healthy 30-year-old adult ingests 100 cells of Listeria, their immune system might neutralize it entirely, or they might experience a mild upset stomach. But what happens if they ingest 1 million cells? Furthermore, hazard characterization accounts for susceptible populations.
like who?
If that same dose of Listeria is ingested by an elderly person, an immunocompromised hospital patient, or a pregnant woman, the pathogen can cross the blood-brain barrier or the placenta, leading to meningitis or fetal mortality. You are charting the severity of the biological destruction across different demographics.
So, identification names the threat, exposure calculates the dose, and characterization details the physiological damage of that dose. Which brings us to the final calculation. Step 4 is 4.6, risk characterization.
Risk characterization is the grand synthesis. You integrate the dose calculated in the exposure assessment with the health damage calculated in the hazard characterization to produce a final statistical probability of disaster.
Wow.
It generates a statement for the regulators. If we allow this soft cheese to be manufactured under these specific parameters, we estimate that out of 1 million consumers, 15 will contract listeriosis and 2 will face severe outcomes.
That is a profoundly chilling mathematical reality. It is the cold, pragmatic calculus required to feed billions of people. It strips away the illusion of absolute safety and replaces it with the management of acceptable risk.
It is cold, but it is necessary. And most importantly, it is never final, which is why the very last substantive point in this microbiological section is 4.8, reassessment.
Reassessment, the admission that the math can change.
The FAO and WHO acknowledge that food safety is not a static law of physics. It is a continuously evolving biological arms race.
Because the variables change.
The variables are always shifting. Global supply chains change their routing. Climate change alters the ambient temperatures during transportation, throwing off the exposure assessment models. Bacteria undergo horizontal gene transfer, developing resistance to standard chemical sanitizers, which changes the hazard characterization. Reassessment means the codex is a living document. We are constantly pulling new data from outbreaks and feeding it back into the mathematical model to verify if the fortress walls are still high enough.
Let's zoom out and take a breath. We have covered an immense conceptual landscape today, entirely by decoding the roadmap of this one foundational document. We started with the geopolitics of the UN, stripping away borders and ideological conflicts to establish a universal language of science. We examined the environmental hygiene of the farm, assessing the uncontrollable risks of nature before we ever planted a seed. We walked through the static, unyielding architectural engineering of a facility and watched it collide with the dynamic chaos of operations, recalls, and relentless sanitation protocols.
We analyzed the psychological challenge of the human variable, distinguishing between a temporary state of cleanliness and the grueling vigilance required to manage behavior, backed by the continuous feedback loop of training.
We tracked the product through the vulnerable cold chain logistics of transportation, traced its lot ID through the market, and handed it over to the final, unregulated handler, the consumer in their home kitchen. And finally, we decoded the massive scientific engines, the critical control points of HACCP, and the rigorous four-step microbiological risk assessments that translate invisible biological threats into manageable mathematical equations. It is an awe-inspiring operational web hidden within a seemingly dry table of contents.
It is a remarkable achievement of global cooperation. But to bring this deep dive to a close, I want to leave you with a final analytical lens to apply to everything we've just discussed. Remember that this specific edition of the Codex Basic Texts on Food Hygiene was published in Rome in 2001. We have just mapped out an incredibly comprehensive, brilliantly engineered fortress of global hygiene.
Right, the blueprints of the compound.
But consider how the world has changed since 2001. Our global supply chains have not just grown, they have become exponentially faster, vastly more intertwined, and infinitely more complex. The sheer volume and velocity of ingredients crossing borders today would have been staggering to the risk assessors of the early 2000s. Furthermore, the advent of cheap, rapid whole genome sequencing means we are discovering novel microbes, new pathogenic variants, and hyper-evolving bacteria at a rate we've never seen before.
So the enemy is mutating faster, and the territory we have to defend is moving at light speed.
Exactly. So as you sit down to eat your next meal, trusting that invisible operating system that keeps you safe, ask yourself this question. Is a framework a geopolitical and operational fortress designed to manage the variables and risks of 2001 truly capable of containing the microscopic, rapidly evolving, hyperconnected biological hazards of tomorrow? Or is the global fortress due for a fundamental, ground-up redesign?
That is a deeply unsettling yet vital question to chew on. When we began this deep dive, we talked about how you just expect things to work, how you trust the system blindly. But the reality of food safety is an invisible, high-stakes war waged every single second of every single day across every continent on Earth. And I, for one, have a newfound, profound respect for the architects who drew up the blueprints. I want to thank you, the listener, for joining us on this deep dive into the Codex. Stay curious, keep challenging the systems around you, and I promise you, you will never look at a mundane food label or a table of contents the exact same way again.